Now, here is the general form for the equation of a conic section, whether it's degenerate or otherwise. But again, we're only going to talk about 3 of those non-degenerate conic sections. Now, I know I haven't formally defined an ellipse or hyperbola, but here goes. If A and C are non-zero, then you and I will have an ellipse or a hyperbola. If A and C are non-zero and have the same sign, an ellipse. If A and C are non-zero but have different signs, hyperbola. Now, if you don't mind, all my examples have a coefficient of B being equal to 0. If B were not 0, then you're dealing with a rotation of conic sections. I'll leave that for you to review. Don't like what you see with a topic? Don't worry about it. I'll make life so much easier when we study linear algebra in Math 33. Now, if it's the case that either C or A is equal to 0 and the other is not 0, then we're dealing with a parabola. And that being the case, these would be the 2 standard forms for the equationary parabola. This would be opening up or down, depending if P is positive or negative, respectively. This is opening right or left, depending on P is positive or negative, respectively. Look at my equation up here. Notice how y has a coefficient, y squared has a coefficient that's non-zero, but x squared has a coefficient that is 0, because you don't see it. So it's definitely a parabola. And since y is being squared, I will transform that equation I have into this standard form, and I want to graph it. Label in the graph the vertex, and label in the graph the focal point. So here I go. What I just erased naturally involves a perfect binomial square for the variable y, and I don't see one. So I'll create one out of thin air. Let me co-locate all the terms involving the variable y to one side, and co-locate all the other terms to the other side. Excuse me. For me to create a binomial square out of thin air, I will naturally complete the square of y. I don't like doing it because the 2's in the way, so let me get rid of it. Now to complete the square of x, I'm going to add I misspoke, didn't I? To complete the square on y, not x, I will add the square of half the coefficient of y and make it legal. That trinomial is indeed equivalent to this perfect binomial square. And now let me clean up a little bit further. Now that being the case, I have a vertex located at 2, -2, and I open up to the right because my p is positive, or the 4p is positive. Now the focal point is going to have coordinates p, 0, whereas p is found to be, well, p is found by identifying what this coefficient outside this binomial is. In my standard form, that coefficient is 4p. But the coefficient of my binomial involving x is 1/2. They have to be the same, so p is equal to 1/2. But p's the distance between the vertex and the focal point, and since I have to move away from the vertex horizontally to the right, I will merely add 1/8 of the x-coordinate of the vertex. And so my focal point is going to be located at 17/8, -2. If you insist on finding intercepts, I'll leave that for you.